Its name has a double meaning. Vega is the second brightest star in the northern hemisphere, but it also means, in Italian, the European Advanced Generation Carrier. Though the name is in the heavens, parts of Vega's roots lie in an earlier American rocket called Scout. This was the start of the Italian space adventure. In 1964, Italy was first in Europe to orbit a satellite, using the U.S. vehicle from Wallops Island, USA. Later, it flew from a platform off the coast of Kenya called San Marco. Then, 30 years ago, Italy wanted to upgrade this launcher. Instead, over the years, the Europeans opted for something totally their own, a launcher that would deliver small satellites up to 1.5 tons, based on know-how developed within European industry. In particular, Vega would be built on technologies in solid propulsion provided for the boosters on Ariane 4 and Ariane 5.
Italy participated to Ariane program, first with small boosters on the first stage, attached to the first stage of Ariane, to Ariane 4. And from this small booster, then the idea was to develop mainly solid propulsion, solid rocket propulsion. And from this booster, we started a bigger investment on the Ariane 5 booster, so the big booster, 237 tons of propellant. So the development of this branch of solid propulsion in Italy came out with the story of Vega.
The Vega program got going in the late 1990s. At that time, another Italian project called Zefiro was developing bigger rocket boosters. Without this new technology, mainly based on carbon filament winding, Vega could not be totally European, but would instead rely on outside help. Zefiro was the backbone of the Vega program and was used in its ultimate design as the second and third stage engines. After a decade of development, in February 2011, a full-scale model of Vega was assembled on the launch pad in French Guiana for tests. An inert or unfilled first stage, the second and third stages, the liquid propellant upper stage, and a payload mock-up. Then, last November, the campaign for the first Vega mission began with the arrival in Kourou of the flight version of the powerful lower stage, which was derived from the Ariane 5 boosters. The trend toward smaller payloads today, Vega size, comes especially in the fields of science and Earth observation. Miniaturization has made satellites much lighter. Vega will deliver these modest payloads into space more rapidly and more economically. She is entering a market that is ready for her now.
In terms of competition, it is in the right position in terms of performance, in terms of capability, in terms of flexibility. I think Vega, once qualified, there will be such a range of possibility to use the launcher that will satisfy more and more customers.
Her maiden voyage from French Guiana is this qualification flight, and it's the one remaining technical test. Antonio Fabrizi, who is one of the fathers of the Vega program, can look back now on all the technical trials, but also on the political challenges.
The technical is something that we as engineers are more used to deal with. The political problems are less predictable sometimes. With the duration of 10 years of development programs of this nature, of course we go through several governments in several countries, and it's difficult to keep together the political team of the concerned member states for a so long period. That's an important challenge, even more than the technical.
The coming of Vega extends Europe's family of launchers, adding to and complementing the successes of Ariane and Soyuz, and opens up a new page in European space history.